Hi everyone! This is the first video I've published in 2026, and since I wouldn't like to start the new year with something extremely complicated, this tutorial will be easy and quick. I'll show how we can simulate a view through something like a small glass blocks using a shader whose code fits on a single line. Before I begin, let me remind you that this year I may not be able to publish a new tutorial every Monday, as I have so far. I'm working on a new project, actually on 2 new game projects, and it takes up quite a lot of my time. In any case, I do intend to record new videos about everything interesting I come across during development, so you can definitely expect new content on this channel, even if it may be a bit irregular. Okay, let's start. This time it's not about any transition between scenes, so we can get by with a single background image. So I'll create the usual scene with a Sprite 2D node and then apply a new shader material to its material property. So I'm right-clicking the scenes folder, create new scene. It will be a 2D scene, and let's call it, I don't know, glass brick. Yeah, why not? Okay, and I'm dragging the usual image from our game screenshot. This one, it automatically created the Sprite 2D node here. And in the inspector, let's do the usual stuff. Canceling centered in the offset section. And in transform, let's reset the position to 0, 0. Very well. Scrolling down to the material section where I create the usual shader material, click it and add a new shader to the shader property. It's called glassbricks.gd shader, type shader mode canvas item, and I'll put it to the shaders folder. Create and clicking again to open it in the shader editor. Very well, and as usual, we'll improve the readability of the shader code by deleting everything that won't be needed. That way, only the fragment function will remain. So I'm deleting vertex and deleting the commented out light. Okay, so at the beginning of the video, I said that the shader code would fit on a single line, by which I meant the code inside this fragment function, of course. The uniform parameters, which we will define this time as well, don't count toward that limitation. And we'll need 2 of them. The first one is used to control the number of tiles in the vertical direction into which we split the image, and the second defines the amount of image distortion in each file. And by file, I meant tile, of course. Okay, so let's go to the uniform parameters section and add them. Uniform float tiles with a hint range and the initial value. Let's start with 10 tiles. Very well, and the range should go from 1 to, for instance, 100, and the step is, of course, just 1. Okay, and the second one, uniform float. Let's call it deform, and another hint range and initial value 0.2, and this time we have the standard range from 0 to 1 and the step 0.01. Great, and now to the fragment function. Our line will start very simply by reading the pixel color at the UV coordinates, which means this color is a texture function applied on our texture and UV. Okay, so of course we don't see any changes, because with this formula we are displaying each pixel of the original image exactly where it should be. If we want to create tiles, we'll need to multiply the UV coordinates by the tiles parameter, like this, times tiles, of course. Okay, so that doesn't look like much, does it? I think the effect will be more visible if we temporarily change the value of this parameter to 3. Let's do it in the inspector and 3 tiles. That's better. However, the image isn't repeated across the other tiles because we cannot add any parameters to the texture variable. We can easily fix that by using the fractional part of this multiplication, which will ensure periodic repetition. So instead of UV times tiles, I will do this fract of UV times tiles. Wait for it. Okay, let's show the whole image. Yeah, this is correct. Very well. The image is still in its original state, which doesn't really match the intended glass brick effect. So we'll use the second parameter to multiply the modified coordinates. So I will multiply that by deform. Okay. Very well. When we now change the deform parameter in the inspector, we'll see that it works like a local zoom. Zoom and zooming out. All right. But it would be better if we shifted the image a bit in each tile, because they still all look the same. And to make that shift depend on the current global coordinates, we'll add it to the UV vector. So I'll just do this UV plus this formula. Okay, we are getting close to the result. But one more adjustment is needed. To center both the tiles and their contents, we'll subtract half the value from the deform parameter from half the value of the deform parameter from our formula, like this. Minus deform divided by 2. Okay, now it's correct. So let's reset the value of both parameters, I mean this just tiles, and we'll get the effect we saw at the beginning of the video. When I now increase the value of the tiles parameter, we will see that the result simulates a view through a ripped glass quite nicely. Let's do it. Yeah. Oh, 100. Maybe it's too much. Okay, and if we were to control the deform parameter, for example, from a script, we could achieve another type of screen blurring. Like this is the original, and let's blur it like this. Or maybe if we increase the number of tiles, it's even better. Yeah, not bad. Okay, let's reset. By the way, you've probably noticed that as the value of the tiles parameter decreases, the black border around the resulting effect gets larger. That's because the deformation causes a slight zoom out, and the texture image, this one, doesn't have any repetition defined. If we wanted to fix this, we could replace it with the third uniform parameter, for which we enable a repetition, like this. Uniform sampler 2D, let's call it image, and activate repeat enable. Yeah, repeat enable. Okay, I will drag our image into this new parameter. And now, instead of texture, we will use image. Okay, the repetition, with this repetition, there is no black border. But of course, if we don't want this repetition at the edges, we can simply go back to the original version with the texture variable. So I will do it right now. Okay, that's all. Thank you very much for watching. As I said, this time we created a very simple piece of code, which has the advantage of being quite fast to execute, so we could definitely find a use case for it. It would probably look more impressive if I used this shader for post-processing of a moving scene, but we can get to that sometime next time. For now, take care, good luck with your projects, and I'll see you in the next video.